Hello, everyone. Good morning, good afternoon, good evening, wherever the world you are. Hope you're doing great and happy all the time. Thanks for taking time and joining in another Saturday in another Microsoft Learning Room sessions. We're so excited today to have Krunal in our stage with an interesting topic related to AI services and GenAI apps with Azure AI. I'm sure this is really an interesting and important topic that to learn AI services in a daily basis. As you can see, my next slide here is mainly and as usual related to Microsoft Learn and the communities within Microsoft Learn. So as usual, make it your homepage because we're all in the same path. Learning about Microsoft technologies from cloud to AI, data, developer technologies, and so on. So this is really important to stay on the path. Making it your homepage will make you to see the updates, learning opportunities in a daily basis. And also with learning rooms from Microsoft Learn, the opportunities to connect everyone together is also another benefit from Microsoft Learn to connect with professionals, with learners, students, everyone together. So try to join to learning rooms, aka.ms/learning rooms, and from Microsoft Zero to Hero to other learning rooms with any other technology category or topic you're interested, and keep the learning going in a daily basis. Especially with the Microsoft AI services, with Microsoft as a leader in the market. So this is really important to learn more about this service. So as now we are in the third session of the month for July, this is so exciting. And we have also upcoming sessions. And it's also another opportunity is also from Microsoft Learn to learn more and connect with professionals all over the world. Professionals like Krunal we have today on stage that we are lucky to be able to hear out from their experiences, to see how they experienced the technology that they worked with for many years. So looking forward to it. As the last slide, I'm going to share about the code of conduct of the community, as usual. So being aware of each other, being friendly and patient, welcoming, respectful, and opening to all questions, viewpoints, understanding differences, and being kind and considerate to others. With that being said, I'm adding Krunal to the stage. Hi, Krunal. Welcome.
Hello, Hamid. Thank you so much. Good afternoon, everyone. Good afternoon, Hamid. Yeah.
Thanks for taking time and joining. It's so exciting. I've
And
just added your slide also here, and I can see that, yeah, this is amazing.
yeah, as I already mentioned, thank you so much for providing me this wonderful opportunity. And
Of course.
again, I'm thankful to you for starting this wonderful initiative. So fantastic. Thank you so much, Hamid. Hello, friends. I think I don't know which part of the world you guys are. If you are from India, it's good evening to you. If you are from Europe, it's good afternoon. I don't think US people are here because it would be early morning. So I don't think
Early
so.
morning again to them. So
Yeah,
if they are watching, so thanks for watching. If
yeah.
anyone in Canada,
So,
because we have also community leaders and members from Canada, America. So if they are not able to join the live session, so it's being recorded now and it will be immediately available after we end the stream.
yeah, so for North America folks, good morning. Two times good morning to you because it's very, very early morning.
Right,
So
right.
here I am today, and we are going to discuss RAG at scale. It's not the topic where we are just going to understand RAG, but we are going to understand how to work with RAG and create production-ready GenAI application with Azure AI Search. So the concept is about scaling. Once your application is running in the production environment, then how to scale that application, that is what we are going to focus here, and what Microsoft is offering nowadays for the various capacity in terms of service, in terms of compute, in terms of token limit, and also that's what we are going to see. And after all, later at end of the session, we are going to see a small demo. So with this, I would like to start the session. Let me start the session with my brief introduction. So I'm Krunal Trivedi. I'm a Microsoft certified trainer, MCT, as well as MCT India regional lead. This is my sixth year as a Microsoft MVP for Azure. And in my daily life, I provide software training and consultancies for IT giants in India, pan India, in North America, in APAC, Middle East, as well as in Europe. Recently, I published a book for AI 900, which is Microsoft Azure AI Fundamentals. And you can see my LinkedIn scanner here. You can scan it, or the URL. You have my email address. Feel free to reach out to me, or even you can see the GitHub URL is also there. So, with this, let us start with the session. So, the first thing what we are going to understand is what is RAG and why we need it. So the thing is, what we know what is LLM, and we all know that LLM is trained over the public internet data. So when you ask any question to LLM, it is having huge amount of data, sometimes which is not relevant to your business domain, or it is not up to date to your business domain, but it is having huge amount of data which is public, the data which is available publicly on Wikipedias, on other platforms like Reddit and all, and it is trained over there, and you get the response from that data. Now now the concept is what, say if I ask a certain question to my LLM model, and say I ask a business specific question, a question specific to my organization, or specific to uh, something specific to my application domain, LLM would not have that data available, or it might not it might not have updated data. So that time it will hallucinate, it gives you a wrong answer, right? And here X comes to the picture, here X comes to the market. So before we go ahead, let me just tell you the technical definition of LLM. So, and what is this technical definition of RAG also? So we all know that LLMs like ChatGPT and Copilot are trained on public internet data that was available at the point in time when they were trained. They can answer questions related to the data they were trained on. And this public data might not be sufficient to meet all of your needs, right? You might want question answer based on your private data. It is like, hey, I mean, what is my organization providing me as a health insurance, or what is the health plan provided by me in my organization, or what is the revenue in last quarter in my organization. And now LLMs are not having this type of data. So solution to this problem is retrieval augmented generation. RAG is a pattern. It is used in AI that uses an LLM to generate answers with your own data. So what I want to do now, I want to feed my business application, my uh, organization specific data to the LLM. And we know technically it is not possible, right? You cannot fine tune LLM with your own data, right? You cannot give this data to GPT, or even if this data is publicly available, right? It will take time to get trained on the LLMs, right? So what to do? And that is what we are going to understand. So if you see, RAG is the pattern. What is this pattern? It helps you to get your private data with the help of LLM. Now, before we go ahead and understand it, let me understand how we can bring a domain knowledge to LLM. So what we want to do is we have our business application specific knowledge, or the organization specific knowledge that we want to feed to LLM, and that's why we have, like, how to bring um, domain knowledge to LLMs. Now, to feed LLM with this business domain knowledge, we have three techniques. The first one is prompt engineering. Now, prompt engineering is the fastest and cheapest way, right? And easy to go if you want to feed your data to the LLM. Like when we work with prompt engineering, we can have, like, few examples we can provide to LLM along with our prompt, few short learnings, one shot learnings. We can set the context over there, and we can feed certain type of data to LLM, right? And it is easiest way, fastest way to go with, right? We have various techniques available, like, chunk of thoughts, I mean, the thought chainings, lot of things we can do. And with these few short learning, we can give certain examples, we can set the context. It's like, man, you have to work like a tourist guide, or you have to work like a doctor, or you have to work like an English teacher, and then you can give certain examples, and that way it tries to understand what context you are talking about. So it is easiest and fastest way to work with. Second thing is fine tuning. In fine tuning, you train the LLM to learn new skill, and now that is most difficult thing because it consumes time. You have to invest money, you have to put your efforts, you need compute powers, and you need huge amount of recent data to fine tune your LLMs to teach them new skills over there, right? So it is pretty difficult and costliest and lengthiest approach. And then it comes with RAG, the retrieval augmentation. Here we make LLMs to learn new facts. Is a pattern that uses your data with LLM to generate specific answer for your data. And when user ask a question, right, the data store would be search first. We get the data from the data store, and then we feed the data along with the prompt to your LLM model, right? So let us understand these things with the help of the diagram. So what I'm going to do is I'm going to share my another screen because I want to draw the diagram. So just give me a second. And I'm going to present again. And here we have this Microsoft whiteboard open. So let us understand this entire RAG pattern. So I'm going to talk about the RAG pattern. How it works. Say you are the user. The user could be anything. It could be you, it could be web application, it could be your mobile app, it could be a bot, it could be anything. And user asks a certain domain specific question to LLM. It is like you say, hey, what was the revenue in January to March quarter in our organization in say Southwest region, right? So you ask that question. But now what happened? That question will not directly go to LLM. So that question goes to your database. It's not the database, but it is your data source. So that question goes to data source. Your question itself is prompt. The prompt goes to data source. Data source could be anything. It could be say, for example, PDF file. You have vector DB, which is very popular in this kind of situation, in these kind of scenarios. Or say you have some organization intranet based website or website. It could be any form of data, right? PDF, indexes, and any form of data is there, right? So your prompt is like, your prompt is what is the revenue in Southwest region in the quarter January to March 2024. That is your prompt. We go to this data source. Here we have our data. That data is vectorized. So this is the vectorized data. I can say this is the vectorized data. And we have indexes. These indexes help to search your data faster. And we get exact match here. Once we get that result here, that exact matching result, then what we do, we feed that prompt and matching result that we give to the other end, that is the LLM. Now LLM applies its natural language processing skills and other skills over there, and then we get the response here. So now in the response, what we have the response which is having LLM response plus this matching result. And now it understands like what in which context I am talking and what is the exact data. Now thing is what tomorrow you have few more files. So you have new files here. Or you have new entries in your vector DB. Or you have new data in your organizational website. We continuously keep on adding that data, and this data would be keep on being indexed. And as a result, when after a few days you make one more request, you might have the new data, the latest data you have along with the LLM. So this is what the concept of RAG pattern. This is how it works. And this entire thing, starting from this data source to attaching the data here along with the LLM, is known as data grounding. So that is how it works. And this is the classic LLM, classic RAG pattern flows, right? This is how it works. So we know here you need to apply the skill of prompt engineering. Then you just um, use RAG to provide new data to your LLM model, and then LLM respond you here. This is how it works. So again, what I'm going to do is, let me stop sharing and let me share back to the another one. So with this, we have clear understanding of what is RAG pattern, how it works, and why we need it. Next is, we understand vector DB and search index. I mentioned that we can have PDF as a data source, organizational data source, or intranet-based website, or even we can have vector DB here. So technically, vector DB is a mathematical representation of structured and unstructured data. You know what is structured data? RDBMS kind of data. You know what is unstructured data? Blobs, files like that. These are the unstructured data. It is like an array. You get an array of vectors. And what is this vector representation? It is the mathematical representation of the number of certain value which are closed on the dimension. So for example, you put tea and coffee and milk. So vector representation of these three things would be closed. And if you put a dog and tiger, so it would be closed. But if you put tea and dog, they would be far in the vector representation in the dimension. So this is what vector database, so technical definition says, is a mathematical representation of structured and unstructured data, similar to what we see in an array, right? And these arrays, you can say, are better suited for and understand by machine learning and AI models versus just underlying unstructured data. So it is heavily used for AI and ML specific tasks. You can see the flow here is, I ask a question and I have the index prepared from my vector DB, which provides me efficient search result. I get the matching result, and then I construct along with the prompt and feed into LLM, which generates the response for me. So what is the task of index here? Okay, we understand this, a vector database is good. It gives you mathematical representation instead of the keyword search and all. But then what is the use of index here? So this RAG uses your data to generate answers to the question, right? And for RAG to work well, you need to find a way to search and send your data to the LLM. And this is achieved using index. And index is nothing but the data store, and that allows your search to find data, to search data efficiently. It is very useful in RAG, and we can optimize this index for LLMs by creating vectors, text data converted to number sequences, right? That's what the vector, and this is what the index is composed of here, right? And this good index usually has efficient search capabilities like keyword search, semantic search, vector search. It's a combination of all of these three. In Azure, we have Azure AI search, and within Azure AI search service, we can create this index, right? So Azure AI provides an index asset to use with RAG pattern. The index asset contains important information like where is your index stored, how to access your index, the connection string, what are the models on which your index can be searched, does your index have vectors or not, what is the embedding model used to prepare the vectors, like embedding ADA2 or embedding ADA3. So these are the embedding models used to prepare the vectors. So for example, your text is Krunal is the trainer. Now, if you provide this statement to your embedding models. It will generate vector for you, right? And that vector is stored in the vector DB along with the indexes, and that index help you to search it. So this is what the concept of vector DB, search index, and RAG. Now scaling the RAG application, that is very important thing. So here we are going to understand scaling the RAG application and what things we should consider. First of all, friends, why we need scaling this RAG application? This is interesting thing. So for example, as an architect, as a solution architect, your duty is to make your solutions highly available and scalable, right? So initially you deploy one enterprise Gen AI application to the production server, and your application is working pretty well. On say first day, you have thousands of users who are making query through your application, right? And it's working fine. The user one came and he asked a question like, I want to visit Italy, and can you just provide me some itinerary for it for 5 days? And your application working fine, providing it the expected result, and he loves it. And then next day you get few more users, and then few more users, and few more queries, few more questions and questions and questions. And what happens? You get lot of requests over there, you get lot of queries over there. And now here you need the scaling, right? Because now when you get more traffic, you have to think about the scaling. Now when you think about the scaling of Gen AI application, friends, what things to consider? What you are going to scale? Are you going to scale your app, or you are going to scale your search service, or you are going to scale your storage, or are you going to scale your compute, or you are going to scale your LLMs, or you are going to scale what you can say token limit? So what you are going to scale here? So all those things we are going to discuss here, right? But understand scaling is very, very important when your Gen AI application goes to production, right? Because eventually people love your application, and you get more and more users, you get more and more queries. Even once a user come, user ask one question and he gets a response. Based on that response, he asks another question, and this way you get long sessions over there, right? So scaling is very important. And while you are scaling it, understand, say you are developing this application for your organization or for your customer, you have to take care of even say cost, right? Because you cannot simply increase the compute, or you cannot simply increase the storage capacity or the partition, right? Or LLMs. No, so you have to think about everything here. So here you can see this is what the typically rack pattern for Azure AI search. So it's a high level summary you can see of the pattern, what looks like. This is the image what we take from Microsoft Learn itself. So it says like, you just start with a question and or a question or request, which is known as the prompt, right? It comes from the app UI, and send it to Azure AI search to find the relevant information, which sends the top ranked search results to LLM. It's like, these search, Azure AI search will search the vector indexes, gets you the response that sends to the LLM, and then LLM uses the natural language understanding and reasoning capabilities of the LLM to generate a response to the initial prompt. This is overall pattern. But then how it works, right? So first important thing here is Azure AI search. This Azure AI search provides input to the LLM, but doesn't train the model. So understand, Azure AI search is not going to retrain or train your model. It just sends the input to the models. And in RAG architecture, first thing is there is no extra training to your model, right? The LLM is pre-trained, as we know, using public data, but it generates response that are augmented by information from the retriever. So here, this Azure AI search works like a retriever. It retrieves the new information for you from your private data source and give it to LLMs. If you understand this pattern here for Azure AI search, so the first you can see we have application or the UX, right? It's like a web app for the user experience, right? This web app provides the user experience. It provides the presentations, context, user interactions, chat application kind of scenarios, right? Questions or prompts from the user starts from this application, right? And it passes this input through the integration layer. The integration layer is nothing but this app server, or we can say the orchestrator here, right? This app server integrates your code to Azure AI search, because when you take any prompt from your application, right, now we need to take that prompt, and that prompt you have to integrate with your Azure AI search, which is what your app server orchestrator, right? And then it does further task of feeding it to the LLM, right? As we see, Azure AI search is the information retrieval system which provides searchable index, query logic, the payload, which is nothing but the query response, right? The search index can contain vectors or non-vector content. Even we will see today when I prepare the search index, right? I will have vectorized data, even I will have semantic and keyword data also, right? But in GenAI, you can say for LLMs, your most of the samples and demos include vector fields, right? However, it's not mandatory, but yeah, almost all the times we go for the vector because it is more suitable for LLM kind of applications, right? And this query is then executed against the existing search engine in Azure AI Search, which can handle keyword vector queries, right? Index is created in advance, so you get the faster response, right? And then that data we are going to feed into Azure OpenAI LLMs, right? So here you can see in this diagram, if you see here, I have, this is my search engine. This browser, this cloud is my Azure AI search, which gets the data from blobs or SQL or Cosmos DB flavor, right? We get the data, we get the response, and now this app server orchestrator feeds the data to the LLM along with the prompt plus the knowledge, and we get the response over here. As we see, we have millions of users now. We get lots of queries, lengthy sessions, and we are getting responses over here. So we need to scale it. So what we do for the scaling purpose, right? First of all, we have to consider many things. First, we should consider about scaling LLMs. Is it possible? Should we scale LLM, or we should scale Azure AI search? What we should scale, right? So first thing we consider is about scaling LLMs, and we should not miss this thing under consideration, right? When you scale LLMs, we should think about scaling tokens per limit, right? So like when you deploy any OpenAI model, right, we get option, right? I'm talking about Azure OpenAI or Azure AI Studio. We get the option which tells you how many tokens would be incorporated, or how many tokens are allowed, right? What is the limit, and can we scan can we you can say, can we scale up these tokens per limit, right? Again, to scale these tokens per limit, we have various options available. We should think about LLM choice, whether you are okay with GPT 4.0 or you are okay with GPT 3.5. You should go for 3.5 turbo or instruct, or you should go for SLM. So this all depends upon the token limit, right? So first thing is token limit you should consider here, right? Again, you can go for on demand or say provisioned capacity PTU, right? So on demand you scale up the tokens, or you just pay for fixed capacity, provision capacity, right? You have to also think about the subscriptions and per deployment rate limit for your LLMs. And we should also lean on retrieval to keep prompts short. So the prompts are short, the less token it will consume, and it will help you to get lengthy response. So that is what scaling the token per limit we should think first. Once you finalize the final tokens per limit and you just scale it, you have the mechanism of keeping the prompt short, and you change your model from say GPT 3.5 to GPT 3.5 turbo or to GPT 4.0, and everything is scale now, everything is fine now. Then we should think about Azure AI search here. So first thing is we try to scale LLM capacity. Second thing is we talk about Azure AI Search. As we know, Azure AI Search is not the small service, right? It's a huge enterprise level search experience provided by Microsoft, right? It's a state of the art technology. Initially it was available as in the cognitive search, but now it's a part of AI search, right? and it's a huge, right? Microsoft has put all the efforts of these all these 1 decade 15 years, right? Starting from Microsoft Bing to Office 365 search, everything is now integrated with this Azure AI search, right? Is a feature-rich vector database we get here, right? We get seamless data and platform integration. So these Azure search you can integrate even with your app service very easily, with your storage, with your other AI hosted services. Azure AI is basic categorized services with M365 and with the fabric, with dynamic. So everywhere we can just put this Azure AI search, and it depends. It's built on enterprise ready foundation. We have lots of framework, securities, everything is available with Azure AI search. So it's a huge thing, right? It's just not one small service we are talking about, right? And here we have increased vector storage and compute capacity. So now, during the build 2024, we get a new announcement. Microsoft announced several improvements to Azure AI Search. What they did, so Microsoft has dramatically increased storage capacity and vector index size with no additional cost. That means in the same cost now. So if understand, if you are a small startup with the less cost, you can have heavy storage capacity and vector index density. And if you are a big enterprise, right, in the same price you can accommodate extra capacity over there and store vector index density, right? So it's one of the most cost of effective option now, because you get more in the same price, right? In addition, vector search now supports quantization, narrow numeric types for vectors. These all are the techniques where you can, like, narrow your search indexes, and you can narrow the size how your search indexes are stored there, right, in your storage, right? It is used to reduce vector field storage, right? And with this case, with this thing, like, you get more storage, right, for the same data, same vector data. So you can apply techniques like quantization and narrow numeric types for the vectors, right? You can go to Microsoft Learn and read more about what is quantization and narrow numeric types of vectors, kind of thing, right? And with these, like, now Azure AI Search delivers an enterprise ready full feature retrieval system with advanced search technology without sacrificing cost or the performance, we can say. And if we take a look on the particular capacity here, so we can see we have increased vector storage and compute capacity. Now Azure AI Search support for larger vector workloads, and the new services will have now 3 to 6 times increase in total storage per partition, right? And 5 to 12 times increase in vector index size per partition. Additional compute backing, the service supports more vectors at the high performance, and up to 2 times improvement in indexing and query throughput, right? So now your vector density is increased up to 12 times, and 6 times total storage limit is increased, right? Microsoft has launched more compute capacity in almost all the tiers. So from the basic tier to very large tier. So when you provision Azure AI Search service, right? So from the basic tier to the large tier, and on each and every tier now we have increased capacity, right? Which is almost 12 times to 6 to 12 times increasing is there, right? We have new set of options for vector search in preview to control performance and reduce storage cost, right? For example, if you store a vector field as an index size of single field, which is reduced to 75% on the disk, right? And we also have some stored property on vector fields to reduce vector storage overhead, right? If you see here, like, if you take a look, if I expand, if you try to understand this new capacity, look at the first SKU. In the basic SKU, previously we have 1 GB per partition limit, which is now 5 GB per partition. And previous storage limit was 2 GB per partition now, which is 15 GB per partition, and previously maximum service size was 2 GB, which is now 45 GB. At the same, if we talk about the L2 tier, right, previously we had 36 GB per partition limit, which is now 300 GB per partition, and 2 TB storage limit, which is now 4 TB, right, and 24 TB previous max service size is now 48 TB, right. So you can see the detailed change, the details here, how the vector index size for each service in each tier is changed, right. And again, this is what you get is at the same cost. So previously, if you deploy Azure AI search, for example, say in the basic tier, right, and you are paying X amount of money where you get only one partition, but today in the same money you get 5 partition, and you get 15 TB of storage and 45 TB of new service size. So for each and every tier now we have up to 6 to 12 times what you can say increase in the partition with the same cost. And as a result, like we just get announcement from OpenAI that as a direct result of Azure AI search scalability, even OpenAI has increased the amount of the knowledge users can upload by 500 times. So this is what when during the bill Microsoft has announced the new capacity for Azure AI search. And as a direct result of this announcement, even OpenAI allows us to now upload around 500 times more data, right? So this is what how big it is, how huge it is, right? And again, everything is at the same cost. So if you are deploying your enterprise grade application, your application is in the production, and if you need to scale it, so 4 things you are going to scale. First, you are going to scale your LLM limit, the token limit, and for that, what you will do, you will find out various options, whether this LLM deployment GPT 3.5 is fine, or you should go for GPT 4.0, like that. You are going to select, even if you wish, you can go to even SLM also. Any SLM is not particularly for only LLMs, right? You have to make sure your prompts are shorter, so you get larger response. It will save your cost, save your token when you are sending a prompt to your model. And once you fine tune the LLM scaling, right, then you have the option to scale the storage limit, the capacity of vector density, and the compute power. And all of these 3 you can scale, right? You can scale on demand, or you can just go with the provision throughput. And this way, like you can scale your enterprise ready application even in the production environment, right? So these are the 4 things to consider. Again, I repeat, we have to scale LLMs, and then we have to scale Azure AI search service, storage, as well as compute. And all these 3 we get even in the Azure AI search, we get at the same cost from basic tier to large tier, right? Now, is increased capacity we get 6 to 12 times increasing capacity we get in the same amount in the same cost. So with these things, now we'll see one small demo. So what I'm going to do is I'm going to create my Azure storage account. With the Azure storage account, I upload some blobs, and then using Azure AI search, I create vectors and index on this search. And then I use Azure OpenAI to deploy the model. So it is like we are going to use Azure AI search, Azure OpenAI, and then I use Azure AI Studio to deploy this entire solution, right? And to chat it. And then I integrate my customized data, customized vectorized index to my solution, to my model deployment. So let us start it first. So yeah, what I'm going to do now is say I'm here in my Azure portal, friends. So let me start it with the Azure portal. And yes, I'm here in this Azure portal, and say I'm going to provision a new resource group here. And I create the new group and say group name is RG02 Hero July. And I just put it in this East US region. I just click on review plus create and create. Once I have this resource group ready, what I do, I'm going to create a storage account. So I just search for storage account, and I just click on plus create, and I just select the same resource group, the 0 to hero July, and just say 0 to hero storage. And it is also okay, it's July, probably it's not taken, right? And it's in the East US region. I just go for LRS, and next I just make sure I have public access enabled. I just click on review plus create and create. So my storage account would be ready, and once my storage account is ready, I'm going to create a container, and in that container I'm going to upload my private data. It is my organizational data, right? That's what I'm going to use here. So meanwhile, yeah, so this is the storage service where I'm going to have my organization data. Next is what I'm going to create Azure AI search service, which will create index on this data, and it would be the vector index. And then that index I'm going to integrate with my model deployment in Azure Open AI, right? And in Open AI, we are going to have few GPT 3.5 deployment, which will provide me the LLM power, and this Azure AI Search provides me the indexing power, and that what we are going to integrate here. So I just go to the storage account and I just go to containers. I create the new container here. My container name is say data container, data container, and I just click on create. So this is what I create this data container. In this data container, let me upload few files here. And yeah, these are the few files. This is my personal documentation for employee handbook, benefit provided my organization, some Northwind health plus benefit. These are some dummy data, but yes, I'm going to import all of them here in this container. So yes, I upload them and they are done, right? So first step, we have storage account having private data. Second step, we are going to create Azure AI search service. Now it is known as only AI search. Yeah, Azure AI search. I already have one service deployed, but let us create the new one. I just want to show you. So I just put it in the same resource group, RG0 to hero July, and I just provide says 0 to hero search service July. I put it in the same region where I have everything else in the East US. And here you can see, friends, this is what my pricing tier. So I get 160 GB per partition, maximum 12 replicas, maximum 12 partitions, and 36 search unit. And if I just click on change pricing tier, this is what from the basic tier to large tier. Now everything is increased here, right? Initially it was 5 GB. Initially it was 1 GB. Now it is 5 GB here. Initially it was say 15 GB. Now is initially it was say 7 GB. It is now 35 GB. So this is what I get the new capacity here, and I just go for this capacity. I just go to next scale and networking, all the default things, review plus create and create. So I'm provisioning my search service here. And we click on create. So once this service is provision, what we are going to do is we are going to connect our blob storage to this search service, and we are going to prepare index, right? And the index would be vector index here. So if you see here, I just go to my Azure AI search service, and we have this option here, import and vectorize data. I just click on import and vectorize data, and it says, okay, so what you want to do, you want to use one lake file or you want to use Azure blob storage. I'm just going with Azure blob storage here. I have my subscription, I have my storage account here, and I just select that data container, and inside this data container, we have our files, 5 6 files I already uploaded here. I don't want to enable deletion tracking or authenticate using manage identity. As of now, I just click on next. And here, now, the thing is what it says, like, to vectorize this thing, you need Azure OpenAI model, because you are going to use embedding model, which takes this file from the blob and create vector data, vector index, right? So what I'm going to do is I already have one model deployment. I already did it, right, which helps you because to save the time. So in my Azure OpenAI, even still I can show you what I can do is let me open this duplicate tab here. And as you all are familiar with Azure OpenAI, but I can just show you quickly. So I just go to Azure OpenAI, and with this OpenAI, you can see I already have this service provision, but you can go to create. You can create new OpenAI service. Once that new OpenAI service is ready, and inside that service, you have the new model deployment, which I already have. So if I just go to OpenAI Studio here, again, in the interest of time, I have deployed it, but I can show you. I just go to deployment here, and in this deployment, I already have one embedding ADA 002 model deployment. So what I do, I just click on create new deployment here, and I select the model, and I select this embedding ADA 002 model, which does this vector embedding for me. So what it does, right, later on, the same model, like here you can see the model is text embedding ADA 002 model, the same model I just used here. So now this model takes my blob storage data, the data from that container, and creates vector for it, right? And I say just authenticate it by the API key, and I acknowledge that it will incur the charges. I just say click on next, and I don't have any vectorized image, or I don't want to enrich any data, AI data skills, like I don't want to extract any text from the image. If you have that image with the text that you want to vectorize, you have to select these options. I just go to next, and it's all about the scheduling where you want to schedule it. I just want to schedule it once, and yeah, once, and I just click on next and create. So what it's going to do is it's going to create an index, vector index for me on my blob data, on my containerized data. So we'll see here, right? Look, you can see it's creating indexer, and once it creates the indexer, it will start indexing process also. So it starts searching. It takes few seconds, probably a minute. As of now, it has searched zero document. It has vector as zero document and 0 byte. But what I can do, I can just go here. Okay, I just close it, and even if I just go to indexes, even as of now, you can see it is in progress, right? This is what my indexer, which is started 18 seconds ago. It is in progress. We need to wait it to complete it. I keep on refreshing. Yeah, and again, just to save the time, I already have the same thing ready with me here in this application. It's already ready with me. I can show you later on. Yeah. So here you can see the one which is already ready it has scanned ultimately say 410 document count. And if I just click on this vector, and here I can just say it's 410 documents, and this is what the total storage vector index size is 2.43. Now you understand, we have increase in vector index size, we have increase in storage capacity, and we have increase in even the compute power also, right? And I just want to search say Northwind health plan. It's coming from the document. I click on search. You can see it's going to search that document here, right, which I have already uploaded. And if This is like keyword search, but if I scroll down here, you will see this is what my vector. This is huge vector. So all my document are in the small chunks and they are vectorized now, right? They are ready to use. Meanwhile, if we check here, what's the status, you get the same thing. So if I just go to indexes and if I just refresh even this thing, I need to refresh the browser for this probably. Yeah, and then you would see here it's like, I get hmm, okay, still not. Let me click here. Yeah, the same thing is that you get 410 documents, same size, and I can just write explain north wind plan and I just get the same data. So this is what my data has been vectorized, right? To create the vectors, what I use text embedded 002 model that I use along with my Azure AI search. Vector data is ready. Now, what I'm going to do, I'm going to feed in this data along with my prompt to my LLM. So for that, I just go to AI Studio. Generally, I just go to AI Studio here, and what we do is say we can create the new project here, and we create the new project. Even we can use existing hub, right? Or even I can create the new hub here, but it takes some time, right? And when I just create this project and hub, then what happen here is if I just go to these all hubs, and generally you get this hub. That's what I just prepared to save the time. And here I have this project with me, and this project has connected resources, right? So I can just show you here. If I just go to settings here, so it is having my Azure AI search, it is having my AI service, it is having my open AI service, blob storage, everything is connected here. And what I did the model deployment here. So if I just go to say deployment option, and here I prepare one GPT-3.5 Turbo. This will give me my NLP power, right? So I create one GPT-3.5 Turbo deployment. So for that I click on create deployment, and I select GPT-3.5 from here, right? I think it is already provisioned, right, for me. And here for the GPT-3.5 Turbo, you can see I'm going to connect it to my OpenAI service, right? So I'm going to connect it to my OpenAI service, which I already created. And look at this thing. This is what token per minute rate limit. As I told you, like the first strategy of scaling your application is what you should try to scale your token limit. So first you have to figure out you are happy with 3.5 or you have to go for 4.0, and then what will be your token limit. So from here you are going to scale your token limit first, and then you try to increase or scale up the capacity of your Azure AI search service. So I already have this model deployed here. And so if I just go to the chat playground, and if I shoot out the question, it's like say, explain the North Wind health plan. And we just see we are expecting the output. Okay, so it's still okay. It's the new one, right? I already have that data. No, I don't have the data. Okay, I'm opening the wrong one. So what I will do, I'll just go to my chat playground here, which is already having data source connected. Yeah, and here when I click on add the data, we can click on add new data source. Then here we select okay. You just go to Azure AI search, and then you select your search service. You also get your search index there. You go to next. You say just I just want to add vector search along with the semantic search. We just go to next. This is the index name, and I just want to do custom mapping. Click on next. Here the content would be the chunk, and the file name would be chunk ID. Title is title, and I just click on next, and I just click on create. Just creating the index, yeah, and I just, yeah, it is there, right? And now if I ask the question, so initially if you see when I ask the question, Northwind plan, where it is. I don't know where it went. Yeah, but here you can see if I now say explain Northwind health plan, it should give me, it's okay. We need to wait for a few seconds before we try it. So let us wait here. Let me clear the chat. Let us wait for a few seconds and then we'll try this thing again. But this is what the overall flow here, right? And yeah, this is how it works. So we'll see. Yeah, we'll wait for a few seconds. We have a few minutes left and then we'll be up and running with this data. So meanwhile, if you guys have any questions, feel free to ask me the questions. And you can see now, so it's already, and you can see now when I search here, I say explain Northwind health plan, I get the response. Sorry, you can see I get the response, and this is like, this Northwind health plans provide coverage for medical, vision, etc., right? And it is coming from my particular chunk. This is what even my document what I have uploaded. So even it gives me the citation and the source also. So what I did first, I use storage service where I upload the blobs data. Then I use Azure AI search service and I create the index. Now what I did here, I vectorize my data. So for that, while creating the index and vectorization, I use OpenAI embedding model. Using that model, I vectorize my data. And then here I use GPT-3.5 turbo model for NLP based conversation. And here I import my data. I connect it to my uh, AI search service. I connect it to my AI search index and Azure OpenAI service. And I connect it to my AI search index. And with this, now I'm able to play with my data. So this is what now it's having the private data, right? We feed domain knowledge to the LLM models, right? It takes time, so we are just doing next. So I just refresh it 2-3 times and now it's working fine, right? But if I remove my data source from here, if I remove the data source and if I ask the same question, this is no man, we don't know, right? So I just remove the data source. I just remove the data source, right? And now if I ask the same questions, explain Northwind plan, and it says, I'm sorry, but I'm not familiar with this term, right? But if I add the data source again, the same steps, Azure AI search, and I select my search service, I select my vector index, I vectorize it, I use custom mapping, chunk as the data, and chunk is the file name with the title. And when I do it, right, so after a few seconds, when again I search, it will give me the domain specific knowledge, right? So that's what we did here, right? So with this, we are almost done with the session, right? Yeah, any question, friends? Yeah, Hamid.
Yes, Krunal, I'm here. You
Yeah,
called me?
yes, so we are done with the session, right, with this. And yeah,
Perfect, amazing. Do we have any questions? Anyone live in the session? Just post your question in the chat, and I will be highlighting it on the screen for Krunal.
Yeah, please.
I see currently we have also a live audience on LinkedIn, but StreamYard doesn't actually show the number of people on LinkedIn, so I'm also checking for the chat questions on LinkedIn side. Uh,
Okay.
yes, perfect. That was an amazing session, Colonel. Thanks for delivering it. I really enjoyed it.
Thank you so much, Amit. Thank you so
Looks
much.
like we don't have any questions. And by the way, the session will be session record will be available immediately on YouTube once I
Okay.
stop the streaming. And beside that, if anyone has any questions in the future, just reach out to us or Chronal or post under the comment because I will be promoting this session afterwards for the recording on our socials. And
Okay.
yeah, hope you enjoyed it. Thanks for delivering, Chronal.
Yeah, thank you so much, Amit. Then, if it's possible, you can just share me the session recording. I can also host it on my YouTube channel, so it would be great to get this visibility and all. Yeah.
Of course, definitely.
Yeah. Thank you so much, Amit. Thank you so
Perfect.
much.
Thank you. Have a great weekend. And thanks
Thank
everyone for
you.
joining.
Thank you so much, everyone. Yeah. Bye.
Bye bye.